All right, today we're going to talk about 3.4, which is Box and Whisker Plot. Okay, we talked about this a little bit last year, but basically, Box and Whisker Plot deals with median. Okay, it's exclusively, that's all it's going to deal with is median. Okay, it's not mean, it's not mode, any of those. It is going to deal with median. Okay, now you're going to have basically 5 parts to a Box and Whisker part. You're going to have the median. Okay, then you're going to have the lower quartile. Then you're going to have the upper quartile. Okay. Then you're going to have the okay. So you're going to have the median, the lower quartile, the upper quartile, the whiskers, and the whiskers are made up of 2 numbers, the lowest number and the highest number. Okay? So the first step, anytime you're doing a Box and Whisker plot, the first step, put the numbers in order from least to greatest. Okay? That's the first thing, is to put the numbers in order from least to greatest. Because when you're dealing with the median, you can only deal with if they're in least to greatest order to find the median. You can't find the median if they're all jumbled up. Okay? So that's the first thing. The second step is to find the median. Okay, we're going to find the median. Third step is find the lower quartile, which is the median of the lower half of the numbers. Now, obviously, I'm going to go through all these steps here in a few minutes as soon as I get them written out. Okay, so we're going to find the median of all the numbers. Then we're going to take those numbers and split them in half. Okay, and then we're going to find the median of the lower half. And then step 4, step 4 is find the upper quartile, which is the median of the upper half of numbers. Number 5 is plot all of the medians on a number line with the lower and upper extremes. Okay, the lower and upper extremes are the whiskers. They're the lowest and highest number. Okay, so an example of what your final product is going to look like is it's going to look something like this. Okay, it's going to look something like that. Okay, this is an example. Now, you will have a number line above it, okay, and I'll show you that here in a second. Okay. All right, so first things first, I have to take and put these numbers in order. Okay? So, what is the smallest number? I believe 34 would be. 34. Okay, then I think it's 38. Then it looks like 40. Then 41. 42. No more 40s. Nope. So we go to 50. No more 50s. Nope. So 65. 71. 82. 87. 88. 91, 93, 94. Barely got it all on there. All right, so that's the first step. Put them in order. Now I'm going to make sure I have the same amount of numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. So the first step is to find the median. Okay? Find the median of the whole set of numbers. Okay? Well, I have 14 numbers. So if I take 14 and divide it by 2 or cut it in half, that is equal to 7. So my median will be the 7th and 8th numbers. Okay, so 1, 2, 3, 4, 5, 6, 7. So it's those two numbers right there. Okay, so I need the number that's halfway in between those two numbers. Okay, what is halfway in between those two numbers? Laney? 68. 68 is halfway in between 65 and 71. Okay? So, my first one then, my median is equal to 68. Okay? Now, I need to find the lower quartile, what I call LQ. Okay? The lower quartile. The lower quartile means I'm going to find the median of those numbers. Okay? Since my median was not one of the numbers, in other words, my median was not 65 or 71, then I have to use them in the lower half of the numbers. Okay? So this is the lower half of the numbers. and I've got to find the median. So I have 1, 2, 3, 4, 5, 6, 7 numbers. Okay? So 7 divided by 2 would be 3.5. So it's the fourth number. So 1, 2, 3, 4. So that's your lower quartile. So my lower quartile is equal to 41. Okay? My upper quartile is the same thing. It is the upper half of numbers, and it's going to be the same. It's going to be the fourth number. Okay? Because there's 7 numbers there. 7 divided by 2 is 3.5, so it's the fourth number. So 1, 2, 3, 4. Okay? So the upper quartile is 88. The lower extreme, which is the lowest number, is 34. The upper extreme, which is the highest number, is 94. Okay, that's a pretty big range there. That's basically 60 points. Okay, so now, I'm not done, but these are your answers. Median, lower quartile, upper quartile, lower extreme, upper extreme. That's the information you're going to put in your box and whisker plot. Okay, so let's look at how we plot it. Yeah, I don't really like that color. Change colors. All right, now, on our box and whisker plot, we got to have a number line. Okay, here's our number line. I'm going to start right here, and that's 34. Then I'm going to go 36, 38, 40, 42. I'm going by twos, obviously. Hopefully this will be enough. May not be. All right. Now, obviously, you could have picked something different. You could have gone by 4s. You could have gone by 3s. You could have gone by 5s. You don't want to go too big. In other words, I don't want to do 30, 40, 50, 60, 70, because then you're just guessing where the numbers should be plotted. The more tick marks, that's what they call those little things on the number line, the more tick marks you can have, the better off you're going to be in being able to tell what your box and whisker plot is really like. But we're going to go ahead and plot these numbers. We'll start with the median. The median was 68. So I'm going to come down here below it, okay, where 68 is, and I'm going to put a dot. You don't have to draw the arrow, okay? I'm just doing that to show you that's where 68 is. Okay? Now, the next thing I'm going to do is do the lower quartile, which was 41, which is right there. Okay, it's a pretty big gap already. Then the next one is 88. Okay, now here's what I'm going to do. I'm going to take those, let me make the little dots bigger, and I'm going to put a box around them. I am marking 68, 41, and 88. Okay, this was the lower quartile, this was the upper quartile, and this was the median. So now I'm going to draw a line right through the middle of the median like that. Okay, so that's your box. Okay, you always want to put the numbers that are associated with the dots the last thing I have to do is do the whiskers. So I am marking the 34 and the 94. And I connect them with a line to the box. Okay? And then I mark those numbers, 34 and 94. And so that is a box and whisker plot. Now, here's how you decide information from the box and whisker plot. Okay? First of all, each one of these segments is 1/4 of the numbers. Okay? Each one of the segments is 1/4 of the numbers. Okay, so if I had these numbers in here, that would be 1/2. Okay, the yellow would represent 1/2 of the numbers. Okay, if I had these numbers over here, then that would obviously be 1/2 of the numbers. Okay, and I'll show you one here in a second where how they're going to ask you things about the box and whisker plot. Now, if you look at, I'm going to draw another one here so I can explain this a little better. Don't worry, obviously there's not going to be numbers associated with this. I just want to show you something. Okay, if I had this example of a box and whisker plot, this distance right here is very small. Okay? So, when the distance between points is very small, then that means you have a heavy concentration of numbers. Okay? When you have a distance like this, when you have a distance that is very large, it means the numbers are very spread out. That means you may have like a 30 and then a 44 and then a 52. They're spread out like that, okay, when the distance is very large. When it's very narrow like this, that means you've probably got, for example, these are just example numbers, you probably have like a 52, 52, 53, 53, 53, 55, 55, 56, 57. They're all clumped in there together, and you have multiple numbers that are the same when the gap is very narrow. But even still, on this graph, this is still 1/4, 1/4, 1/4, and 1/4 of the numbers. Even though that's a tiny little part of the square, it still represents 1/4 of the numbers. It just means that 1/4 of the numbers are very close together. Okay, when it's very small distance like that. Okay, now let me see here. Everybody, look at example 3 at the top of page 125. Okay, look at example 3 at the top of page 125. If you will see the very small, between the first little red box and whisker plot, it says New England Patriots beside it. Okay? There's a very small concentration in the lower quartile of numbers. Okay, the box is real narrow between the 2 points. Okay, everybody see that where it says 17 and 20.5. Okay, so they had what that means is they had a heavy concentration of scores in a game that were between 17 and 20 points. Okay, obviously you can't have 20.5 points in a game. Everybody understands that, right? In a football game, you can't have 20.5. Okay, there's no way to get a half of a point in a football game. So what that is, it's obviously just the median of the scores. Okay, well you will look from 31.5 to 44. That's a pretty big chunk, and so that means that there was multiple games that they scored anywhere between 31 and 44 points. But it wasn't like 42, 42, 43, 43, 44, 44. Okay? It was more like maybe 31, 35, 39, 40, 42, 44, something like that. Okay? Now, here's what the type of things they're going to ask you. Okay, still looking at example 3. All right? In the New England Patriots, okay, with the New England Patriots, how many of their games did they score less than 21 points? What fraction of games did they score less than 21 points? Everybody look at the Box and Whisker Plot and tell me how many games, what fraction of games did they score less than 21 points? Matt? Huh? Which is, right. About half their games, they scored less than 20 points. Now, let's look at the St. Louis Rams right underneath them. Okay? About how many games did they score less than 21 points? Matt? Close to a fourth, but really less than 1/4, right? Because they go on up to 25.5. Okay? So, if you look at the two graphs, okay, obviously, who had a better season as far as scoring points, St. Louis or New England? St. Louis. Because the box is further ahead of the Patriots box. Okay? So that means their scores were higher for the most part than the Patriots were. Okay? That's why the box is further along. In other words, as we look at those two boxes, if this is a box and this is a box and they're being compared on the same number line, then this one would have the higher numbers. Okay? This one right here would have the higher numbers. Because it's further ahead, that means its median scores are higher than the other teams. Okay, obviously there's the line in the box, all that. But that's what it means when you're comparing two sets of information. Okay? All right, let's look at let's look at number 1 on page 125. Number 1 says, in exercise 1 through 4, tell whether the statement about the box and whisker plot is true or false. Okay, number 1 says, the upper extreme is 93. Is that true or is that false? That the upper extreme is 93. What is it? Okay, some of you say true, some of you say false. Okay, the upper extreme is the highest number. Okay, the upper extreme is the highest number. What is the highest number? 117, so that would be false then. Nicole? Because the highest number, if you look at that graph, the highest number is the furthest point to the right. Underneath that point is 117. And so the upper extreme is the highest number in the box and whisker plot. Okay, and so it's 117. Now, number 2 says the median is 82. Is that true or false? Laney? True. That is true because the median is the middle number in the box. Okay, now obviously it's not in the middle of the box. Okay, so that means there's a higher concentration of numbers from 82 to 93. Okay, that fourth of numbers are all right there closer together. Okay, now number 3 says the lower quartile is 58. Is that true or false? True, because the lower quartile is the median of the last little dot on the box. Derek.
How would you write a conclusion about the data of a whisker plot?
Box and whisker plot? Well, usually when they want you to write a conclusion, they're wanting you to compare 2 different box and whisker plots. Okay? So like the one we just did with the St. Louis Rams and the New England Patriots, we wrote a conclusion. Now, obviously, conclusions are going to be different. In other words, you and Matt may come up with 2 different conclusions about the same data that could be possibly true. Okay? So like on the New England Patriots, St. Louis Rams, we said, hey, St. Louis Rams obviously scored more points that season. Their games were higher point totals. That's a conclusion. You could also say that, like, for example, the lowest scoring game that the Patriots had was 3. The lowest scoring game that the Rams had is 15. So obviously they scored more points. You could say something like that, and that would be true. It's probably not the best conclusion you could have from the data, but it is a conclusion that would be true. And so that's what usually they're going to do. Now, there is occasionally where you have to come up with a conclusion about just one box and whisker plot. Okay? So, for example, let's say something real weird and say that the one on 1 through 4 was representation of ages. Okay? Obviously it's not, because not many people live to be 117. Okay? But let's say this was the ages at a family reunion. Okay, well, you could say everybody was above 43. That's a conclusion you could make. You could also say that over half the people there were above age 82. Okay, so that's a conclusion that you could give for just one box and whisker plot where you're not having to compare them. Okay. Let's see here. Number 4 says the upper quartile is 117. Is that true or false? False, because what is 117? Upper extreme. Good. All right. Now, turn the page to page 126. Okay, it says, number 7 says, choose the set of data that is displayed in the box and whisker plot to the right. Okay? So, to figure out what it is, then you've got to figure out which one of those sets of numbers have those medians. Okay? Yeah, I know. Life is hard. Get over it. Okay? So you've got to figure out which one of those sets of numbers have a median of 20. And so what you got to do is you got to take the numbers in set A and put them in order, and then figure out what the median is. If it has a median of 20, then you've got to figure out what the lower quartile is. If it is 11, then you got to make sure that, so you just got to do those two sets of numbers. Okay? Now, 8, 9, and 10, you're going to actually do 3 box and whisker plots. Okay? Number 7, I just told you what to do with number 7. You got to take set A, put the numbers in order, see if it has a median of 20. If it doesn't, then you know it's set B. If it does, then you got to check all the other numbers, the lower, well, A, let's see here. Okay, they both have, I was fixing to say you could just check the lower and upper extremes, but they both have a 1 and they both have a 39, so you can't see it by that way. So you just have to figure the lower, upper quartiles and the median of those two sets of data and see which one is the true set of data. I would assume that they're going to have the same median, but I don't know. Okay, so you're going to do a box and whisker plot on 8, 9, and 10. Then 11, 12, and 13, you're just going to analyze the box and whisker plot that's there. Okay? Let's see here. I thought there was one. That was last year. Yeah. That was in 6th grade. I'm remembering one from 6th grade last year that I thought was this year, but it's not. So, your homework is not a lot. Okay? Going to be very small, but there is, there are obviously more work to it than normal. We're going to do 3.4, 1 through 13, and then we're going to do 29 and 30. Okay? Now, 1 through 5 we've already done. Actually, 1 through 5 we've already done. Okay, so you just got to look at your notes, and because number 5 wants you to do a box and whisker plot of those numbers. Well, we already did a box and whisker plot of those numbers. Okay, now only got about 4 or 5 minutes left, so don't have a whole lot of time left. Something else? No, I think that was it.